Hi everyone, we're looking at quadratics today. I'm gonna go over the three forms first. So we've seen a lot of equations in general form, y equals ax squared plus bx plus c. This doesn't tell us a whole lot about our quadratics, so we like our quadratics in forms like factored form. This tells us about our roots and what our vertical stretch factors are. I also like my equation in vertex form, which tells us, of course, where the vertex is and what our stretch factors are. It's really important that you remember that in this book, standard form is vertex form. Okay, standard form is vertex form. How can we tell a quadratic from these different representations? And in a graph, the graph is a parabola. Okay. In a table, we say the second difference has to be constant. And we'll go ahead and show you how to do that. So I'm going to take the difference here. 8 minus 2 is 6. 2 minus 0 is 2. 0 minus 2 is negative 2. 2 minus 8 is negative 6. That would be my first difference. If that were constant, then the graph would be a linear graph. But it's not, so I'm going to try and take the second difference. 6 minus 2 is 4. 2 minus negative 2 is 4. Negative 2 minus 6 is 4. And so I can see that my second difference is a constant 4. When that happens, this shows that we have a quadratic pattern. All quadratics have a second difference that's constant. In an equation, there are two variables, so x and y. And the highest degree is a second degree, and all the exponents in our parabola have to be whole numbers. So y is equal to x squared plus 2x plus 1. X to the first power is technically a whole number there. Okay, we're going to change from standard form to standard form, which is, remember, actually vertex form. And then we're going to find the x-intercepts from standard / vertex form. Okay, this is general form. Y is equal to ax squared plus bx plus c. So I'm going to subtract 9 because what I want to do is complete the square. Negative x squared minus 6x. I want my a value to be positive, so I'm going to factor out the negative. Plus 6x and then plus something equals g of x minus 9. All right, so in order to get my c value here, I use the big X. I put my b value on the bottom, which is 6. I have to split that evenly, so 3 plus 3 is 6, and then 3 times 3 gives me 9. The top number c is what I put into my completed square. Okay, so I'm adding 9, but whatever I do to one side, I better do it to the other. But I have to be really careful because right here is a negative on the outside. So I'm not actually adding 9, I'm subtracting 9 to both sides. So I get g of x is equal to negative 8. Okay, g of x is equal to negative minus 18. There we go. Is equal to negative x plus 3 squared. I can see what my factors are in the middle of my big X. And then I'm going to add my 18 back to the other side. So g of x is equal to negative x plus 3 squared plus 18. That is my standard form / vertex form. All right, now we're going to solve for the x-intercepts. And remember, x-intercepts are any number, comma 0. So my y value is going to be 0. I'm going to start with my equation. G of x is equal to negative x plus 3 squared plus 18. And then for y, I substitute in 0. Okay, subtract 18 for both sides. Negative 18 is equal to negative times x plus 3 squared. I'm going to divide by negative 1. So I get 18 is equal to x plus 3 squared. I'm going to square root both sides. When I unsquare something, I get plus or minus the square root of 18 is equal to x plus 3. And then I'm going to subtract 3 from both sides. So negative 3 plus or minus the square root of 18 is equal to x. The square root of 18 would be 9 times 2. So that's negative 3 plus or minus the square root of 9 is 3 times the square root of 2 is equal to x. And that is that for that problem. Okay, we're going to write the equation of the parabola in standard form or vertex form. And our vertex is 1, 3, 1, 2, and passes it through the point 3, negative 6. How do we do this? Well, let's set this up in vertex form. Y is equal to a times x minus h squared plus k. And let's start filling stuff in. I have h and k so far. So y is equal to a times x minus 1 squared minus 2 plus 2 because k is positive. All right, I have 3 unknowns, but and so I need to solve for my a value, but I can see out here I have a point that is x comma y. So I'll plug that in. Negative 6 is equal to a times 3 minus 1 squared plus 2. Negative 6 is equal to a times 2 squared plus 2. I'm going to go ahead and subtract this 2 right here. So I get negative 8 is equal to 2 times 2 is 4, so 4a. And then divide by 4. I get a is equal to negative 2. Then I can see that my equation is y is equal to negative 2 times x minus 1 squared plus 2. All right, minimums and maximums. A parabola has a minimum, so it looks like that, or a maximum if it looks like this. We call this concave up. And this is concave down / frown. And this is smile. Okay, our graph is concave down when a is less than 1. So the stretch value is less than 1. And if the stretch value is less than 0, okay, so like y is equal to negative 2x squared, we'd be facing down. And we're concave up when a is greater than 0, so like y is equal to 1/2 x squared, greater than 0. Okay, last two, we're going to state if the graph has a minimum or a maximum, and then also what the vertex is. Okay, so looking at this problem, I can see that we are in standard / vertex form. So my vertex is my h and my k value. So we're going to be at 3, 1. And my a is equal to 2, which is greater than 0. So the graph is going to be concave up. Concave up, which means that it has a minimum value. Okay, see, our minimum value and our maximum value. So up has a minimum value, down has a maximum value. Okay, the next one. We have to change this into vertex form. So we are in general. Let's change to standard / vertex. Okay, so let's see. Y, I'm going to add 3 to both sides. Plus 3 is equal to, I'm going to factor out the 2. 2 times x squared plus 2x, because I need my a value to be 1, plus something. I'm going to go ahead and big X this. So 2, my b value on the bottom. Split evenly. 1 plus 1 gives me 2. 1 times 1 gives me 1. So I get plus 1. What do I add to the other side? I do 1 times 2, giving me 2. So I get y plus 5 is equal to 2 times x plus 1 squared. I get those from my big X. And then subtract the 5 to the other side. So y is equal to 2 times x plus 1 squared minus 5. My vertex is -1 comma -5. My a value is greater than 0, so this is a minimum value. Minimum. It's an absolute minimum and a relative minimum.